Hi, my name is David Tu. I'm an application scientist at Keysight Technologies. And in this video, I'm going to show you a neat little trick to use a single DMM to measure both voltage and current at the same time. This normally takes actually two DMMs to measure voltage or current, and then you have to sync up your measurements together using some external program. But with a neat little trick and a couple of unique features on our Truevolt DMMs, you can easily measure both voltage and current with one DMM. So let's go ahead and get started. To start off with, I'm going to configure the DMM into DC volts, and then I'm going to turn on this feature called DC volts ratio. With DC volts ratio, it's actually a mode that's used to get the ratio of two different voltages at the same time. So this feature's normally used for measuring DC volts 1 and DC volts 2 as shown in the picture here. There are a couple of limitations with DC volts ratio. One is that you can't change ranges, it's limited to the 10 volt range. And two, that the two voltages have to be within 12 volts of each other. So now, what I'm going to do is I'm going to turn on the key feature for measuring this volts and current thing at the same time. So I'm going to press this display button and select secondary measurement and select the input/reference. So what this allows me to do, it allows me to measure both DC volts 1 and DC volts 2 on my display here. So input is the input side, and then ref is on this send side. From here on out, we're going to ignore this top display and just focus in on this two measurements here. Going back to the diagram, if we add in a resistor on the DC volts 1 side, say a 1 ohm resistor, we can actually convert voltage readings into a current reading. V over R equals I, which is Ohm's Law. So by adding in that resistor, any readings on DC volts 1 will now be a current reading. In order to actually measure both voltage and current at the same time, we actually have to put in DC volts 1 in series with the power supply. So in this diagram, you see that the DC volts 1 and the 1 ohm resistor is in series on the bottom supply of the power supply. Now that I've added my 1 ohm resistor on the input side, I'm just going to take a quick measurement. And you can see that's pretty close to 1 ohm. If you want to be really precise, you can actually make this 1 ohm measurement before and use that as a calculation later on. But for our purposes, we're just going to use 1 ohm. And now what I'm going to do is I'm going to connect up my power supply to the circuits. And on the power supply, you see that the power supply is outputting 5.487 volts, and it believes that it's outputting 0.219 amps. So let's go back to the DMM and see what our voltage and power measurements are. So the input side is DC volts 1. You can see that the current, if we divide by 1 ohm, is going to be 0.215 amps. So that's pretty darn close to what the power supply is. I actually believe that the DMM is going to be more accurate. And on the voltage side, we actually are measuring 5.258 volts. So that's going to be a little bit lower than the power supply measurement, just because we are creating a voltage divider with our R load and our 1 ohm shunt. So you have to accommodate for that voltage burden that the 1 ohm shunt is going to add to the circuits. So as you can see, I can now measure voltage and current at the same time with a single DMM. By using an external shunt, I can calculate V over R equals I and convert this voltage measurement into current and measure both voltage and current at the same time with this single DMM. Hope this helps, and I appreciate you guys watching. Thank you.